Let's do some examples of computing limits now that we have one further tool in our limit toolbox, that is L'Hopital's rule. And remember, L'Hopital's rule tells us that if we have the indeterminate form in our limit of 0 over 0 or infinity over infinity, we can instead take the limit of the derivative of the numerator divided by the derivative of the denominator. Note that this is not the product rule. This is different. We're taking the derivatives of the numerator and denominator separately. So let's start with this first example. I'm going to go ahead and rewrite it. Take the limit of x squared minus 6x plus 5 over 10x minus 50 as x goes to 5. So this is a rational function. If 5 is in the domain of the function, then we can just evaluate the function at 5. So if we do so, we get 25 minus 30 plus 5 over 50 minus 50, which is 0 over 0. And 0 over 0 is one of our indeterminate forms. Okay, so we should say this is an indeterminate form of 0 over 0. And that tells us that we are allowed to use L'Hopital's rule. So that's what we're going to do. We take the limit as x goes to 5 of the derivative of the numerator, 2x minus 6, divided by the derivative of the denominator, which is 10. And now we take the limit as x goes to 5. Again, we have a rational function. And this rational function is continuous on its domain, so we can try to just evaluate it at 5. And we get 10 minus 6 divided by 10, which is 4/10. And there is our answer, 4/10. Okay, we originally started with an indeterminate form of 0 over 0, and now we have 4/10. Okay, let's try another example. We have the limit of x squared minus 4 over x squared plus 2x minus 8 as x goes to 2. So if we try to evaluate this rational function at 2, we get 4 over 4 divided by 4 plus 4 minus 8. And in this case, we get 0 divided by 0, which again is an indeterminate form. So when you are doing these problems and you come up with an indeterminate form, you should write which indeterminate form that is. We have lots and lots of indeterminate forms, so you should write it down. And then when you use L'Hopital's rule, as we are going to do in this case, you need to indicate that you're using it. So that is sort of the justification behind what you are doing. So the derivative of the numerator is 2x, and the derivative of the denominator is 2x plus 2. So now our limit becomes the limit as x goes to 2 of 2x over 2x plus 2. That's a continuous function, so we can just plug it in. And we get 4/6 or 2/3. Okay. Notice that we also could have, at the point we noticed this was an indeterminate form, we could have taken this same limit and instead of using L'Hopital's rule, we could have factored it as x minus 2 times x plus 2 over x minus 2 times x plus 4, and said this function is the same everywhere except for 2 as the limit as x goes to 2 of x plus 2 over x plus 4, and also get 4/6. So this doesn't negate the other way that we know how to find a solution to this problem. It just gives us another tool in our toolbox. No matter which way you do it, you should get the same answer. So let's try the very last problem. This is the limit of e to the x plus 4x over x cubed plus 2 as x goes to infinity. So if we were going to try to evaluate this function, we would have infinity on the top and infinity on the bottom, and that would be our indeterminate form. So that tells us that we are allowed to use L'Hopital's rule. And so we get the limit as x goes to infinity of e to the x plus 4 divided by 3x squared. And we could try to evaluate this. And again, we get infinity over infinity, and that's our indeterminate form. And so we get the limit as x goes to infinity of e to the x over 6x. And you might look at this and say, okay, I'm going to try to evaluate this again, and I still get infinity over infinity, which is an indeterminate form. But what you'll notice is that the denominator is actually changing quite a bit each time the degree is going down by 1, while the numerator stays as e to the x. So we're going to do L'Hopital's rule one more time, and we get the limit as x goes to infinity of e to the x over 6. And this time we don't get infinity, we get infinity over 6. Okay, and that's infinite. Now, so it's not that the limit technically doesn't exist, but we can say more about it. We can say that it is infinite. It's got an infinite limit. Okay, there are other indeterminate forms other than 0 over 0 and infinity over infinity, and we have to deal with those in a slightly different way, and those will be in another video.